So I would like to know about your backgrounds, what are your skills, and how would you like to contribute to a project?
So currently I'm in my third year. I'm pursuing BTech in Electronics and Communication in Bennett University, Greater Noida.
Okay,
So and now I'm doing a project related to FPGA only, which is implementing neural networks on FPGA.
okay, that's
So this is my
okay.
I'm currently pursuing electronics communication and I'm under training in VLSA.
Okay,
My skills are about Verilog, system Verilog, and Python.
okay, that's good to know.
Okay,
Uh,
ma'am.
So, we started this initiative as a part of our community so that we will working upon collaborative projects as a part of community and we will come up with some open source IPs. So that was the vision behind starting this initiative. So our first project which we will doing is the FPGA based Power Analyzer. So have you worked with Questa Sim before?
Yeah, ma'am, I tried it, but not so much knowledge about it.
Okay.
no ma'am.
So I will give a short introduction to it, how to work with that. And let me tell you the architecture of our system. So before that, let us start. Do you know anything about FFT?
Fast Fourier transforms.
Yes. Would you like to tell what do you know about it?
I don't know about, but it is advanced version of digital Fourier transformation.
Yes. So let us start first with the basic concepts of FFT. So my screen is visible, right?
Yes, it's visible.
Yes, ma'am, it's visible.
So let us start with FFT basics. So would you anyone like to become the co-host for this meet? So Ayush, I'm making you the co-host. Admit the new people joining. Okay.
Sure, ma'am.
Okay. So, in your college, you might have studied DFT. So, FFT is a faster computational algorithm for DFT. So, still computation. Okay. So, basically, what it does, so it converts a array of time domain. So, let us have a array of time domain. So, this is our array. We'll just have a basic introduction to F50 today. And so, with the help of F50, we convert this to the to a array of frequency domain spectrum. Okay, is it okay for you?
For you? Yeah, ma'am, it's okay.
Yes, ma'am, it's okay.
So we have n samples here. So here also we have given n samples of time domain, and here also in the output we will get the n samples. So here we will do denoted by td second, and here we will denoted by b b at z. So what does this b at z means? So this is the bidirectional bandwidth. So how do we calculate the sampling interval? So, so let us talk about, we have the n samples here, n equal to 0, 1, 2, 2, n minus 1. At the timestamps of 0, 1, 2, 2, here n minus 1. So how we will calculate the sampling interval here? So TD upon total number of samples will be our the sampling interval. And how we will calculate the sampling frequency? So let us look upon it. So sampling interval is denoted by delta t is here. So our sampling frequency will be 1 upon delta t. So it will be denoted by n by td. So this is the sampling frequency. So now how we will calculate the maximum frequency? So it is denoted by um, f max is equal to bb by 2 is equal to fs by 2. So what is fs here?
Sampling frequency.
Sample
Yeah,
frequency.
yes. Just like uh, how do we calculate the sampling frequency? So we have seen here. So it is. So what the frequency domain arrays which we got after giving the time domain arrays to the FFP. So we will get it like this. So this. So these are our n samples. So BB is our bidirectional bandwidth. So it is the array of frequency domains uh, spectrum. So typically this works with magnitude and a phase. We will denote it like this: f equal to 0 to n minus 1. So now how we will find the delta f here? So it is dB by n. So this is clear to you. So now, so f, one more important thing to know, that f max is equal to fs by 2. It is also known as the Nyquist frequency. So now let us, we have seen a basic introduction to FFT. So let us now move to the applications of that. Tomorrow we will look into the more mathematical uh, aspects of FFT. Uh, so tomorrow we will dive deeper into the mathematical aspects of FFT. So today, would you like to tell some important applications of FFT? Anyone here? So, Dasu, would you like to tell how anyone know how did FFT originated? The
I
concept
mean,
of
it's mathematical computation purpose, man.
yeah,
Like high computationals, like
okay,
floating computations. Yes, ma'am.
okay. So so FFT came into the existence through war. So it was driven by the Cold War era to detect covert nuclear weapon tests. So it led to the nuclear wars. So basically, it was made for the war. So so it is useful in real-time signal processing, and it is useful in communication, audio and audio video compression and scientific instrumentation. So let us now look after how to use the Questa Sim IDE for by which is by Intel. First, you will have to download the Questa sim from the website. So here is a detailed documentation how you can download the Questa Intel's FPGA edition software. So you can visit here and you can install the light edition also uh, for uh, getting started with this software. So let me show you the. So from here you can download the Intel software. So after downloading, you have to set up the installation process. Um, so then you will get project. You will get a IDE like this. So let us start a new project on this. Is my IDE visible to you?
Yes, ma'am.
Yes,
It is
ma'am.
visible.
Okay. So let us start with a new project. So actually, I have our project, one project already here. But when you install this Intel Questa software, you will face some issues. So I thought of discussing with you also that you don't spend a lot of time on that. So when you set up when you run the RTL simulation, you will get lot of license issue with Questa software. This so this is the this is the Questa sim IDE. So it have issues initially with uh with license. So how to solve it? So in your in your environment variables, you will have to properly specify the path of the license file, as you can see here, and you will also have to specify the bin path. The path. So this is the bin 64. As you can see, I have specified the path here like this. You will also have to specify like this, and then and how to actually find this path, this license file path. So it is given in the Intel software. So wait. So here you can see here we have the license setup. So here when you click on get no cost license, so it will give you a license here, as you can see here. So it will give you the path also to that. So this, and you will have to use that path for your license. So try to set up the IDE if you are working on this project. Have you worked on Questa Sim before?
No, ma'am.
No problem. But it is good to have idea of different FPGA tools like AMD tools, this Questa Sim and everything, because it helps you understand that what are the advantages and disadvantage of different IDEs. So try to work with this IDE. It's a good software.
Yes, ma'am.
Okay, so now I will introduce with some basic function on this IDE. So how can you So in this software in Questa Prime Lite Edition, you will get many IPs here. You can see here, here are there so many IPs. Is it visible to you all?
Yeah, ma'am, it's visible.
Yeah. So we have the filters. We have FIF filter. So this is the mega functions by Intel. So we have transforms. So here we have the FFT IP. So let us see how this Intel IP we create IPs with Intel Mega Function. A short introduction. So here you have to give name to your IP and click OK on that. So here you have to decide the parameters for your FFT. Either you need bidirectional, reverse, forward. So how you will understand about different parameters given in this IP. So for this you will have to study the Intel documentation where it tells about the IP about this IP. So wait a minute. I will so first you can search for Intel FFT IP documentation. So as you can see here, I have got the guide, the user manual for using this FFT mega code function. So for understanding this, you must have basic idea how FFT works, and you will they have given introduction about every parameters which they are asking here, like this representation, data input, bandwidth. If you study this documentation, you will have clear idea that how it is working. So it will be a good idea, a good thing that by next week you get a understanding how this FFT mega core function is working, because with this we can optimize our design, and we are not just going to use this FFT mega core function in our design. I would encourage you people to go through some research paper regarding FFT and come up with some innovative architectures. So let's see how to make IP. So when you select all the parameters, you get the FFT IP. So I have already created it. So I will give a demo of how to use it. So how you will add a new IP in your design? Let us see. So click on File sections. Here, uh, Actually, when I first got started with this software, so I did not give name to my FFT IP, so it is named with unnamed. So you can give your own name like FFT1, FFT2, whatever name you want to give to your IP. So you need to install. So if you want to create some block diagram, wait a minute. It is so now I will tell you that how you can create block diagrams with the IP which you have generated. And one more thing, very important thing, because this will this is something which you will not find on internet forums, but it helped me because when I was running the simulation, it was showing lot of license issue. But when I corrected this, my simulation was working fine. So I would like to tell you this. So when you specify the so you can have different EDA tool for simulation with Quartus Prime Light Edition. So you can use Model Sim, whichever you like. But when you download this Quartus Prime Light Edition from Intel website, you get Quartus Intel FPGA platform for simulation, Questa Intel FPGA platform simulation for simulation. But if you download the previous version, you will get support from for Model Sim also. So it's your choice. You want to use the latest Quartus Prime Light Edition or this. And when you are specifying the path here, make sure it is correct one. So and when and make sure that you use this when you specify the path, use this symbol at the last, because if you don't give this your path, it will not be able to detect the path for getting this Questa Intel software for starting the simulation. So let me show you the path directory also where this Questa Intel is there. So on you will go here. So here my Intel FPGA tools are installed. So here you can see. So here I have the bin file. So you need to specify this directory. So where in this you will find a Win64 folder here. So you will have to specify this path. If you want to use Questa Intel software for running the simulation, just copy it and paste it here. And when you paste it, use this slash sign also after that. Then it will work fine. So let us now open our project. So now how to create such block diagrams on Intel software. So uh, as you all know, I gave a basic introduction how to create IP using this uh, tool of Intel. So here we have this transforms, we created a FFT IP. So when you will create, so you will get a folder here. So this is my folder where FFT IP is created. So now for creating block diagram, you need two important files for creating that. One is the .sip file and other is the .qip. So when you go on to synthesis folder, you will find this QIP file. Is it visible to you? So this is the QIP file which I was talking, and the simulation and the .sip file. So this is the .sip file. You need these two files in your directory if you want to create a block diagram. So you add it here. You will apply the changes and click on OK, and you will get us. And when you click it here, double click on this area, you will get it here. See, I have unnamed. This is our FFT IP. You have to just click it, click on OK, and you will able to make the block diagrams. So I created many IPs like control, the NCO. So this was a basic introduction how to create block diagrams. And now I would like to tell you about some interesting features of Intel. Like you can like this is not there in Xilinx, so you can create a Verilog instantial template. So now I have created a instantiation for this. So now how to access that file? So go to the file sections. So here you can see I have created some instances. So this is created using that feature. So Intel Questa Sim helps you in creating instance of the design automatically. See here, it have created an instance for me for the FFT design. So let me simulate the entire design, the work which I have done till now. So how to simulate the design? So this is our test bench. So you will have to make it global. Set as top level entity if you want to simulate it. So this is our test bench. We have the FFT wrapper. So in this we have FFT instantiation inside, and we have the control module for that. And this is a NCO with which we are giving the waves to our FFT. So if you want to uh, uh, so how do you compile design on Intel software? So just click on start analysis and elaboration, and it will start working. So I'm removing this file from this directory. So it will compile the design, it will elaborate also. We will have to wait for that. So now our design is successfully compiled, and now we can do the simulation. So how you will learn the simulation? Go to the tools section, run simulation. So click on RTL simulation. So it take some time for loading because this is a very big design. So this is our simulation. So now how you can convert it to waves? Wait, convert this to decimal. So this is our FFT which we have made. So how to so what design I did for this? Let me explain you that. So till now, anything you want to ask regarding this tool?
The project itself, like the analyzer you to implement.
Which one?
The entire project itself.
Yeah, I
Like
am
what are the objectives and
explaining.
applications?
Yeah, I'm telling you all. So wait a minute, I'll tell you. So till now, So yes, we will take the wait. We will get the data from ADC, and we will initially, for the simulation purpose, we are using the NCO IP by Intel for generating the waves, because we have presently not dumped our program on FPGA, so we are using NCO. So it is numerically controlled oscillator. So let me give a introduction about this IP and how to use it. Wait. So you will have to go to the signal generation part. You have to click here, NCO. Give a name to your IP. You will have to see, you have to make it a single output, dual output, codec, multiply based. So you will have to experiment these aspects, like how they work. So you can here change the clock rate. So we use 40 in our case, 40 hertz. So this wait a minute. So this is the our phase increment value which we have taken for generating the sine waves. We and then we will be writing a very long code to interface the ADC. And then we will create a FFT input interface. We will create a endpoint FFT module. Then there will be FFT output interface. Then we will create a write master module. And we will integrate a embedded processor. For Intel, it is NEOS. And through UART, we will send messages to the PC. So, is this design flow okay to you?
Okay, so basically the FFT is working as a communication channel for the messages through which we interact with the processor, right?
Yeah.
Okay, got it. Got
So,
the objective.
what kind of design we have done till now? So, let us have a look on that. So, we created a FFT module. Actually, two FFT module. One is for the current, and other is for the for the voltage. And we have a control module, made a control module for this control for FFT. So for connecting all these modules with each other, we have created a FFT wrapper.
So the control module for FFT, what it does, basically it processes various frequencies to the FFTs. Or like
Yeah.
any other, yeah, okay.
So all these will give uh, so it will give each of this module will give real and imaginary values. So we will create a square root IP, and then we will create a adder here, and then there will be a square root IP. Here also we will do that. And then we will give it to the cortex. So a actually I have also explored these things from research paper. So I'm also learning this. So then it will give the output, and then we will integrate this with the embedded processor, and we will integrate with UART, and at the last we will create a MATLAB GUI also for this. So if you want to learn how this Cortex works, you will have to read the Intel uh, documentation. So in that they have given the detailed documentation for this. So this will be our design. So are you okay with this? And
Yeah, it looks fine.
in this, initially we are using the Intel Mega function for this FFT. But we should think of some innovative ways of implementing this FFT on our own. So we will explore some research papers.
Yeah,
Like,
sure. We can explore in that area.
should we write a square root algorithm or what?
No, Intel have a IP for that also.
Okay.
So this
Ma'am,
is,
what are the prerequisites of this project, ma'am?
see, you should have some knowledge, some basic knowledge about FFT. So let us now discuss the basics of PSP is a plus. Have knowledge of EFT first because FFT is the faster form of this FFT only. Second, digital electronics, very low, and you should uh, get used to this Questa software. Have idea that how to use the IPs and everything. Yeah, that's all we need in this. And
Yeah, ma'am.
we have to work on ADC and SPI interfacing also. Yeah, we will interface ADC with SPI. So this is our first community project. So we will be developing the projects which are actually not available on internet. We will be coming up some interesting IPs and we'll do some really innovative work as a part of this community.
Ma'am, what will be our system? Like, it's a floating point or fixed point system?
So we have implemented with fixed point only presently.
Okay, ma'am.
Ma'am, what is the difference between floating point and fixed point, ma'am?
It's just a representation of numbers. That's all.
Yeah.
Like decimal and integer?
Yeah. If when you come to fixed point, there are some standards like Q15, Q415, Q15 not 15. So, and in floating point also you'll get a single precision, double precision, half precision. That's in floating point. When you come to fixed point, it's Q15 representation and 4.15 representation, something like that.
Yes.
Okay. Thank you. Thank you.
Am I correct, ma'am?
Yeah. Yeah.
Thank you.
So let us go through our code also once. So this is our F50 wrapper module. So here we have a instantiation of F50 and we have a control module. So this is our control for FFT. So we have implemented the counter for 1024 point FFT here. So we are feeding the signal here We are So we will be understanding this design in more detail in our next meet.